In this chapter, you're going to learn how to build models, mathematical models, and solve them using linear programming. We're going to approach these problems in two different ways. One is going to be the graphing method, which is a very simple method. This is how it used to be done. You can only do very simple problems. The other method is going to be using Excel and Solver. But before you do that, you need to understand how to formulate a problem. A problem formulation has multiple stages, multiple steps that you have to take before you get to solve for the answer of the objective. The first thing that you need to understand is the problem itself. What are they asking you? Make sure you read the problem. Make sure you ask questions if something is not clear or if you think something has been misrepresented. Ask questions. So the first step, understand the problem. The next step is to describe the objective. What are you trying to solve for? In general, there are only three things you're going to be doing in this class, and basically in any linear programming model ever you may ever encounter. You're either going to maximize, minimize, or solve for a specific number. Usually it's probably break even, so it will be solve for zero. But in 80% of the time, you're going to be maximizing. And in this case, this problem 7.1 RMC, you are doing exactly that. You are maximizing profit in this case. Yep, you're going to maximize the profit that you're going to be making by selling a product, which we're gonna cover in just a second. Okay, so what's your objective? Max profit. All right, you're gonna max the profit. Right now, once you know what it is that you're trying to do, you need to figure out, well, based on what? What are the variables here? Well, the variables are the two products that you are going to be producing. Those two are going to give you that profit. And in this case, is a fuel additive and a solvent, right from the problem. So give it a name. So we're going to call the fuel additive, we're going to call it F, and that's going to be tons of fuel. And the solvent is going to be S for solvent. Also measure in tons. The measuring is not important right now. We are not going to do. I don't think we're going to do any problems that will require a lot of thinking about the measure, the units. So, what constraints do you have? Excuse me. What constraints do you have to achieve this maximum profit based on these two variables? You're always going to have a constraint. I don't care what it is, or which planet you're in. There's always going to be, at the very least, one constraint, usually more than one. In this chapter, we are going to be playing with just a few constraints. I can tell you that by the end of the semester, you'll be playing with 20, 30, or maybe more. So it's very important that you understand the material that we're covering this week. So what are the constraints? So looking at the book, and I'm just looking at the textbook. Let's see. First constraint, the number of tons of material 1 used must be less than or equal to the 20 tons available. So right now, okay, so apparently there are 3 materials, all right? So let me write that down as well. Material 1, material 2, and material 3. So it seems this fuel and this solvent, both of them are made with 3 materials. It could be 3 resources, it could be 3 compounds, 3 materials, okay? Number 1, 2, and 3. And they're telling us, let me make all this red so you can see it, you too. And they're telling us, again, that the number of tons of material 1 used must be less than or equal to the 20 tons available. All right. So how would we write that in a mathematical? First, let me write it down so I don't forget. So tons of material 1, let me call it M1, is less or equal to tons of M1 available. Okay, so basically what it's saying is don't use more than what you have. That is very simple. It's a very simple constraint. If you're given 100 tons of material 1, you cannot use 101. You must use no more than 100. Okay. Number 2, the number of tons of material 2 used must be less than or equal to the 5 tons available. Oh, they're already giving me the, oh, perfect. So I know, so total, sorry, I'm going to jump back to the first one. It's less or equal to 20, because they're telling me that material 1, okay, is given to you at 20 tons. 20 tons of material 1 are available at the very beginning. So do not use more than 20. So the next constraint is constraint number 2 is tons of material 2. Let me, cannot be more than what is given to you. And in this case, you are given 5 tons of material 2. Okay. Number 3, the number of tons of material 3 used must be less than or equal to the 21. Okay, so then we have 21 tons of material 3. So that means that, again, don't use more than what you have, and you have 6. Okay, that's it. All right, excellent. The next step is one of the difficult ones, because you need to write the objective, which is your objective is to maximize profit, but you need to write it based on the decision variables that you figure out in step 3. Okay, so let me build more space here and separate it. Okay, so the objective is, again, to maximize profit based on sale of fuel and solvent. Okay. Now, profit, as you know, is just a formula of cost and revenue. Now, in this case, we don't worry about cost because it's not being given to us. We're just going to worry about. The problem tells us that each ton of fuel sold, you make $40, while you make $30, so a little bit less, when you sell solvent. Okay, so I'll write it here. Fuel at 40 and solvent at 30. All right. Okay. Okay, good. So now you're going to write a mathematical formula that links all of these concepts, this idea, the idea of a quantity being increased and some revenue, some profit in this case, I'm sorry, talking about profit, some profit that comes from the sale of each of those products and the quantities that you're going to figure out at the end. So the formula is simple. You want to max 40 times F, which is fuel, plus 30 times S. What does this mean? This means that we want to maximize the profit, which is given by this formula, right? Which is $40 times each unit of fuel sold plus $30 times each unit of solvent sold. Okay, so let's just run an easy example here. Imagine that you sell 1 fuel and 0 solvent. Well, then your formula will be 40 times 1 of fuel and then 30 times 0 solvent. So 40, you knew that. That was pretty easy, right? Okay, what if I say that you're gonna sell 100 fuel and 50 solvent? Well, you can just go right here to the formula. Let me see where, I don't know where you get to see it, sorry. I do this. So it's 100 fuel. I'm just changing it right here in the formula. Now I'm selling 100 units and I'm gonna sell, I think I said 50 of solvent. There you go, 5,500, right? That's simple. Now, I'm just throwing some numbers there. I don't know if those numbers are maximizing our profit based on our constraints. We're going to figure that out, okay? I'm going to delete this because this was just an example, okay? So again, that is your objective. That's your mathematical objective. You need to maximize 40 times F plus 30 times S. Now you're going to do the same thing with the constraints that you define in step 4, okay? But you're going to write them based on your decision variables. You'll see what I mean. So let's start with, let me put in C1 here, okay? C1 right there, right? So your first constraint is that the number of tons of material 1 used must be less than or equal to the 20 tons available, okay? Now, how much of each am I going to use? The problem tells you that the amount of each that you use in the production of fuel and solvent is actually different. It is not the same. It's not a one-to-one comparison. So there's a table, and I'm just going to build it right here, okay? So fuel as material 1, material 2, material 3. I should have done this before I started the video, but okay, doesn't matter. 0.4, 0.5, 0.6, 0.3, 0.2. What this tells us is that, let me do that. That's what I meant to say. Okay. What this is saying is that the production of fuel, for every ton of fuel, you need 0.4 of M1 and 0.6 of M3. Okay? Solvent actually requires all 3 of the materials. As you can see, it requires a little bit more of M1. It requires M2, which is not requiring fuel, but it also requires some M3, but actually is half of what is required for fuel. Okay, these are the ratios. So you're going to write these things, these variables here, these constraints. I'm sorry, I didn't mean to say variables. These constraints. In terms of your variables in a mathematical way. So this is how you do it. So the very first one is, remember, is don't use more than 20 tons of M1. Okay, so M1 is required in the production of 4. As a matter of fact, 0.4 is required for fuel and 0.5 is required for solvent. Now, the addition of those two, the amount that you use in both, cannot be more than 20. It can be 20, I'm sorry, cannot be, yes, correct, more than 20. It can be 20, just not more than 20, okay? So you see what I did there? 0.4 which is the amount of material 1, times the amount of fuel that you're going to make, plus 0.5 times the amount of solvent that you're going to make, cannot be more than 20. Okay. Now this sounds very complicated. This is not complicated at all. This is, if you ever baked or if you ever cooked anything, think about ingredients, and if you're making multiple dishes or you're making cakes and bread, you need to know that because you only have so much flour and you're going to make so many cookies. So in a sense, you do this in your head. So it's actually pretty simple. Then you move on to the next one. The second one is actually pretty easy because material 2 is only used in the production of solvent, and you need 0.2 per ton. So it's just 0.2 times S. But that cannot be more than 21 tons because you are given 21 tons of solvent. C3, your third constraint for material 3, is going to be same as material 1 because it's used in both products. It's going to be 0.6 times fuel plus 0.3 times solvent. And that amount that you're going to be using cannot be more than, I have them backwards, right? That's 21, this is 21, I'm sorry, and this is 5. Sorry about that. Yep, 5 and 21. I apologize for that. Technically, at this point, you're done. You have formulated, you're done in terms of formulating the problem. You're not done with the answer. You haven't even figured that out yet. But you're done formulating the problem, except there's one final step that you always need to add, which is you need to add your 2 non-negative constraints. The non-negative constraints tells you that no matter what you do, you cannot make a negative amount of fuel or a negative amount of solvent. Mathematically, this is needed for our formulation to work in Solver and other software packages. You need to tell that to the software, to the computer. Okay, so I'm going to add 2 extra constraints, C4 and C5, and these are going to be fuel cannot be, has to, oh, well, 2 ways of writing it, but this is the easiest way, has to be greater or equal to 0. 0, it's okay, just cannot be less than 0. And solvent is the same thing, greater or equal to 0. This is, right now, this is it, you got the problem formulated. All you need to do is now write it in an elegant way, which is going to be max 40F plus 30S, that's your objective. I have a hard time typing. Subject to the following constraints. That constraint, this constraint, this constraint, this constraint, and that constraint. You can also write these 2 constraints, you can actually combine them and write them like that, a little more elegant, okay? And that's it. Now you're done with the formulation.